Hey everyone, Rob here from RisingEdgeIndustries. I wanted to put together a brief video that is kind of an overview of the DR500 data recorder product line, discuss some of the top bullet points about its functionality, characteristics, some of the design drivers, form factor, as does an introduction to the product line. So you can see in the webcam image here, there's 2 units, and this is just a standard pack of cards. So from a dimension perspective and form factor, you can see this is a side view here of one of the units. This is a top view, and so its footprint's a little more square and smaller than a pack of cards. From the top view, the interface tongues here for the PCBs. This is the after the unit. This is a side view of the unit where there's a battery pack here on the bottom side, and then the PCB 2-part housing assembly here on the top side. And you can compare that to the standard pack of cards. Here you can see the thickness, just a standard pack of playing cards, the thickness versus the DR500 housing thickness. It's about twice as thick as a pack of cards and a little bit smaller footprint. And over here I can pull up some of the documentation here, and we can see that the overall footprint of this is fairly small. The dimensions are in here, so we'll pull this up really quick. And the unit is about 2¼ inches by 2.41 by about 1½ inches, 2.25 by 2.41 by 1.42. And so that would be the dimensions of these units right here. So it's pretty small. It's a handheld device. It can be embedded in systems pretty easily. The housing could also be modified for custom application and mounting. And so it's got part of the reason it's so thick is the embedded battery pack. Here takes up half the thickness is the battery pack that comes embedded and potted in the unit. And we'll talk a little bit more about that in a minute. So I guess one of the other form factor things that's key in this development is there's a high quality Glen Air USB 2.0 communication interface. This is the custom USB cable. It's based on the MWDM Glen Air connector, metal machined housing, potted cable, and same with the connector over here, metal machined housing shell, and this is also potted and embedded in the unit. And there are mounting locks, screw locks on the connector, and threaded socket head screws on the cable, so you can screw this down, it won't come out. You plug it in, it powers up, as hopefully you can see on video. There's a blinking live light, and we'll go over some of this just briefly. But this is the interface, ruggedized USB interface, and then the physical wiring interfaces here on headers and vias, actually on the PCB tongues. So then this is the first production unit of 2021, and they all come in these standard 3-part potted housings, powder coated black for right now. RisingEdgeIndustries part number and serial number. So if we take a look at the CAD for this, we can see some of the interfaces, how you interface to the product via the connector we touched on a little bit already, and then also some of the headers. And so because this is designed for ruggedized and shock environments, most of the interfacing is done by actually soldering sensors into the device. So right here is the USB 2.0 plug and play micro D interface that you can see right here in the webcam shot. And down here, these are 4 user interfacing I/O LEDs. So these tell you if there's been a problem internal to the device. These are the 3 operating mode green LEDs, and you can see one of them blinking. So that's the alive and up and running in idle state LED blinking here. So that's one of these 3. The 2 others are busy, units undergoing operation, and then there's an LED on the end to denote whether the unit's been triggered or not. The header over here on the side is mainly a power and sensor biasing header. So you have unregulated VCC, which is 3.54 volts. There are 3 power rails on the device that are exposed to customers. So you could power external circuitry or bias sensors with any one of these 3. The VCCH is high precision sensor biasing, some grounds, and then right here there's a bootloader discrete in case the unit needs to be flashed and the COM link has an issue for some reason. There's actually a hard discrete for bootloading, so customers can flash these devices. The whole product can be flashed remotely at the customer site with just a release of firmware images. So if there are any bugs, we can fix that and get a new firmware update out on the website, and that's a very easy process. The 2 LEDs here are battery charging, which you can also see on this unit. It's charging now. This is the amber LED, orange LED here on the side. That's this one on the board edge here, and the green LED indicates power system's good, and I think you can probably see that as well. That's a little tough to see, but it's right next to the charging light, and that light's just kind of a hardware hardware discrete indication that the power system's good, and then this is basically an indication that all of the embedded code's up and running and the device is ready to go. So those 2 really tell you the health of the unit. Here next to the LEDs we have external power input, so customers here can plug in their own power system, 6 to 12 volts, and power the device indefinitely off of a separate system if the battery runtime is not high enough. So that can work for extended run durations, and it's just a plus and minus. So you wire that in and control that externally. Next to that is the power enable. The device is normally on, and shorting this turns it off. So if you want to power off the unit, you just close a connection between these 2 vias in this 2-pin header. The main driver for that is to eliminate any risk of failure for a mechanical enable, such as buttons, switches, jumpers. We want the device on and up and running at all times, and this also works well if this is in a flight system that has an umbilical, and when the system with the DR500 pulls away from the umbilical interface or bulkhead, you break that connection, it opens, and the unit can power up arm and trigger itself in flight to be up and running in a very short period of time. So that's the power enable. Here on this unit, this is going to end up being an engineering unit for us here internally, and so there's just a 2-pin jumper here, and I have a 2-pin header, and when we install that jumper here, you can see that the unit shuts down, everything powers down, and then the discrete charge circuitry will come back up. You can see the amber light comes back on. There's no green power light though, so the unit's now just powered off charging. So that the power system handles battery command and control whether any of the embedded logic devices are on or not. This is a discrete controlled design. And you pull that off, the unit powers up, configures itself, is ready to go, the power system's on, and then it sees the battery's not full and begins charging. But that can be wired out to a bulkhead or any other interfacing a customer might need. J1 is the biggest header on here, and this is where all the sensor harnesses are plugged into. So from here over is sensor interfacing. It's 4 differential inputs. The 4DE, actually you can see here in CAD, is 4 differential ended channels. So DR500 is data recorder 500,000 samples per second. So max data rate, channel configuration, and then SH for shock hardened. And so this area is all input channel data. Over here there are grounds, there's another voltage rail, and there's also a trigger input, a discrete trigger input to this device we'll talk about in a little bit. And so this is the main sensor interfacing header right here. And so all of these provide direct soldering capabilities to increase reliability. And so it can be a bit challenging to work with. You do need a good iron, even maybe a microscope, just for quality. And another feature that's pretty cool, we thought was pretty important. It's a product designed for engineers by engineers. So these 2 vias allow customers to run out the status LEDs through a bulkhead. These 3 vias allow customers to run out the internal operation indication out to a bulkhead. So you can run all of the headers out. You can run power enable, external power input, as you'd expect. But what's really cool about this device is that you can run the LED indication of every LED out through a bulkhead to an external display device, whether it's another LED circuit or a multimeter. And that's really helpful for anyone on a range or a test facility. If you need indication and this is embedded in another system, then you can run these signals out, get the indication you need, even though you don't have access to the device. And it's not a high pin count to get this information. You can also run out the DP, D plus, and D minus USB signals and a ground to get USB access that you would usually have through this connector. You can actually run out here through little headers. Generally not recommended. Noise could induce signaling problems and cause issues with operation, if you're feeding noise in your USB link. But if you need to do that, it's there. This device is designed to be extremely accessible and transparent, so engineers can really do a lot of modifications if need be. Another benefit here is that if this link somehow does go down or get damaged and you have data in the product, you have a second way of getting into the COM link to download, do command and control. So this hopefully will alleviate some risk where, with a lot of use, if a failure does occur, your data is still capable of getting out of the unit. So I think this covers the mechanical side of this overview. I don't want the video to go too long, and it's already coming up on 15 minutes. So this should cover the form factor, most of the basic information about the product, what the interface is, how large is it. If you have any questions, you can go to RisingEdgeIndustries.com. There's plenty of documentation that we're going to look at in the part 2 of this overview video here. There's a brochure that describes briefly some of this stuff, how the unit works, what features does it have, and then there's also a data sheet for the unit that has a large amount of information, some of the top level functional attributes we'll talk about next, but then specific performance parameter tables, and there's also some examples of use in here. So feel free to go check that out, and you can contact us. The contact email support address is on there, so just send us an email to support@RisingEdgeIndustries if you have any questions or there's any interest. And check out the next video to hear more about the different performance highlights, parameters, and some of the features of this product line.